All right, guys, so here's a quick overview of solving one-step equations. We'll talk a lot more in class, and obviously as we move to two-step and multi-step, it'll be kind of the same thing, and we'll revisit this a whole lot. So first of all, we have our standards over here, if that's something you're looking for. Create equations in one variable and use them to solve problems. Include equations arising from linear functions. All right. Our essential question today was how do you solve an equation that contains a variable? So we did some practice. So when we're solving equations, we're using the properties of equality. The first one would be addition, which says that adding the same number to both sides of an equation keeps the equation true, which we also refer to as equal. So since it's an equation, just like a scale, if you're adding the same amounts to both sides, then it's going to stay balanced. Same thing with subtraction, multiplication, and division. If you do the same thing to both sides evenly, then it stays equal and balanced. Now, what we're usually doing are inverse operations. We're trying to isolate the variable, which means get the x or whatever variable it is all by itself on one side, and we use the properties of equality that we just talked about and inverse operations. Now, inverse, I like to think of them as reverse. The book also refers to them as opposites, okay? But an inverse operation undoes the operation. Now remember, in math, these are our stars: addition, subtraction, multiplication, and division. The opposite or inverse of addition would be subtraction. And same, subtraction would be addition, multiplication would be division, and the opposite or inverse of division would be multiplication. So we're going to use that with the idea of the properties of equality to solve equations, right? You have to isolate that variable. That's what solving the equation is. So here's our first example, and you can see we have this plus 3. Remember, we're trying to isolate the variable. So to get the x by itself, I need to get rid of this plus 3. The quickest, most efficient thing is probably just to subtract 3, because plus 3 and minus 3 is 0. And if we have x plus 0, we'll just have x, and we've isolated the variable. Now, try to keep this as simple as possible. Some people get overwhelmed by what they're supposed to do. You can do whatever you want on an equation, as long as you do it to both sides. So here, I could have added 7, but you could see that would have been not isolating my variable. I would have actually ended up with x plus 10. So that doesn't help me, but I could have done it as long as I did it to both sides. So you look for what is going to help you get to the answer the fastest. We're all about efficiency, okay? So plus 3, and if I subtracted 3, those equal 0. So x plus 0 was just x. All right, and I had to do the same thing to the other side. Picture that scale. If I'm taking 3 pounds off one side, I have to take 3 off the other side as well to keep everything equal. So here was a U-try. You can pause it if you haven't already, but you should have tried this one in your homework. We had y plus 2 equals negative 6. So now this one they did it inline. You could have just, like if we'd covered this part up and just had the minus 2 under each of these, but this is showing it inline. And you can see that the 2 and the negative 2 actually equal 0. Okay, so by getting that 0, get this. All right, so getting that 0, believe it or not, I'm trying to, so this is going to equal 0 because a plus 2 and a minus 2. So we end up with 0 there. All right. Now, on the minus 6 and the minus 2, if we go back to that idea of party or a battle, a party is if the signs are the same. So since these signs are the same, there's no battle. They're just joining together as a whole group. Okay, as Mr. Shives likes to say it, the negativos. So we got the negativos, negative 6 and negative 2. All right, so they just join together, and there's 8 of them hanging out. All right, we'll see one where there's a battle here coming up. So once again, we've isolated the variable. Now, if you're want to, especially like in a test or something, you can plug that back in and check to see if it works. So let's see if my pen works. It wasn't earlier. All right, so I'll try to do it with my mouse, which will probably look super ugly. So I could have done -8, plugged it in, +2, and see if it equals -6, which it does. My goodness, that's bad. All right. So once again, I'm able to do whatever I want, but I chose to subtract 2 so that I isolate my variable. I had to subtract 2 from the other side because whatever I do to one side, I have to do to the other. All right. So here was another example. Notice this one's subtraction. So the opposite of subtracting 3 is to add 3. -3 plus 3 is 0. And then I had to add 3 to the other side to balance it back out. So I wanted to add 3 to the right side. I had to add 3 to the left side to balance it back out. So -7, this is one of those battle ideas. There's 7 negatives and 3 positives. And you could almost picture, if we started lining them up, that these 3 positives would take on 3 negatives, but after the battle's over, there would still be 4 negatives that survived. All right, so we've got the b equals -4. Once again, these over here, okay, went to 0, -3 and a +3. So once again, if you didn't already try this one, you want to pause it. And what we're looking here is a -8. So the opposite of that would be to add 8. So I'm going to add 8 to both sides. I add it on here and I add it over here. This side, -8 plus 8 is 0. And here we had a battle. We had 14 negatives, 8 positives. Okay, so these 8 positives would have been able to take out 8 of the negatives, but there still would have been 6 negatives that survived. All right, once again, you could go plug back into the original equation, and we would have had -6 and -8. That's a party because they're all negatives. So 6 and 8 is 14. So we had 6 negatives, 8 negatives. Together we have 14 negatives. Here's an example with multiplication. So the opposite of multiplication, or the inverse, is division. Now, when we're doing division and multiplication, what we're actually doing is creating a fraction that's equal to 1. This isn't mystically going to disappear right here. A lot of people do this and just think everything went away. But what we really did was we replaced it with a 1. 4 over 4 equals 1. So we have 1x. All right. Now the other side is our baggage. I wanted to divide this side by 4 to create that x. I have to divide this side by 4 to balance it back out. Whatever I do to one side, I have to do to the other. All right. Here's another. We have multiplication. So same thing. This is the you try. So pause it if you haven't tried it yet. But what we look, we're not focused over here yet. We're focused here. To undo a multiplication of 15, I can look back at my notes, but it's division. 15 over 15 is 1. 1 times x is x. And then 10 over 15 actually reduces to 2 over 3. So that's our simplest fraction. This one is division. So the opposite of division would be multiplication. So I multiply this side by 4, and I multiply this side by 4 as well. This side I wanted to, so I created that fraction that's equal to 1. This side I had to. Now, for those of you that struggle, you can think of this as a fraction. Anytime you have a whole number that's not a fraction, you can place it over 1 to make it a fraction. And then you could see how we'd have 4x over 4. All right, and once again, that gives us our 1x. That gives us our -36. -4 times a positive, or sorry, -9 times a positive 4 would be a -36. So here's the you try. If you haven't already tried it, pause it and try it. This is division. This is division of 3, so the opposite, the inverse, would be to multiply by 3. So I want to do this. Well, if I do that, I have to do this because I have to do the same thing to both sides. Here, they cancel out. Remember, that doesn't mean they mystically disappear. That means they made a fraction that's equal to 1. So 1 times r is r, and 19 times 3 was 57. And once again, I could go plug it in, 57 divided by 3, and it's 19. All right. One last one, and this is a little advanced. If you don't get it today, we'll be doing it quite a few times, but it's meant to make your life easier, believe it or not. Anytime you see a fraction, there's actually two things happening. It's multiplication and division in one problem. But for us, what we're going to do is try to nail both of them at the same time by multiplying by the reciprocal. Remember, the reciprocal, which is also known as the multiplicative inverse, is just the fraction flipped over, because when we multiply them together, we get 1. 5 times 4 is 20. 4 times 5 is 20, so that's a fraction that's 20 over 20. 20 over 20 is 1, so 1 times m is m. Now this one I could do any order I want. Remember, I can write this as a fraction if I want by doing that. 28 divided by 4 is 7. 7 times 5 is 35. Or I could have done 5 times 28 is 140. Divided by 4 is 35. And once again, you're allowed a calculator on this one, so you could just do 5 times 28 and then divide it by 4. So you try. If you haven't tried it yet, pause and try it. So we have a fraction. We're going to multiply by its reciprocal again. So in this case, I'm multiplying by 4 over 3. Remember, this becomes 12 over 12. Some of you just cross cancel, which is beautiful. Okay, I love that. The 4's cancel out, the 3's cancel out. But whenever you're canceling, what you're actually doing is leaving a whole bunch of 1's behind. So this becomes 1. If you had done it the other way, it's 12 over 12, which is also 1. Now here, remember, I can think of the 12 as 12 over 1. So 4 times 12 is 48. Sorry, still trying to do this with my mouse. 48 divided by 3 is 16. Or I could have done 12 divided by 3 is 4. 4 times 4 is 16. Both ways get me to the answer of 16. So don't try to overthink this, what we're doing. This one's harder, so if this freaked you out, go back to maybe one of the ones that was simpler still. And just, this is division of 3, so I need to multiply by 3. And if I multiply one side by 3, I have to multiply the other side by 3. That's how we keep everything equal and balanced. I hope this helps.